Hello everybody, welcome into another lesson. So today we are going to do more factoring of quadratic equations, and after today we will know how to completely factor quadratic equations, because in the next lesson we're going to use factoring of quadratic expressions to solve quadratic equations. So today we're going to do the type, again, you have here the standard form of a quadratic equation, ax squared plus bx plus c, where a is your coefficient on the x squared term, b is your coefficient on the x to the first term, and c is some arbitrary constant. This time, however, we're going to do this with that coefficient on the x squared term not equal to 1, so it'll equal anything but 1. We're going to show you how you factor that. This will be the only example where we'll have a negative coefficient on x squared. So you notice here you have negative x squared minus 5x minus 4. So the coefficient's definitely not positive 1 like a normal one. The coefficient is negative 1. You always want to have the coefficient of the x squared term be positive. So if it's negative, you're automatically going to factor out a negative 1 from this whole expression. You got to get your x squared term to be positive. That'll override everything else. So right away, we factor out a negative 1 from this. So factor out that negative sign. Inside the parentheses, you would end up getting x squared plus 5x plus 4. Right? Because if you distribute the negative sign, it'll turn it back into what we originally had. So now we can see, can we factor what's inside the parentheses? Well, I think so. Since inside the parentheses, the term on the x squared term is a coefficient of 1, the coefficient's 1, we only got to worry about adding factors of 4 that would give you a middle coefficient of 5. And in this case, inside the parentheses, everything's positive, so you only got to worry about positive factors of 4. So if we add 1 and 4, you'll get a middle coefficient of 5. So keep that negative sign outside the parentheses. This would turn into the x plus 1 times x plus 4. So what you end up getting for your result here would be negative of the quantity of x plus 1 times the quantity of x plus 4. So that's how you would approach a leading coefficient being negative when it's on the x squared term. But for the rest of these, they're all going to be positive, which is the good news. So what if we had something like, let's say 2x squared plus 7x plus 3. So we have 2x squared plus 7x plus 3. Okay. Well, what you have to do then, the idea is you want to take factors of your leading coefficient, which is the coefficient on the x squared term. So factors of 2, you have, of course, 1 and 2, right? And again, your x squared term should always be positive. If it's not, factor out the negative sign, and then deal with finding factors of the coefficient of the x squared. But in this case, everything's positive, so we only got to consider positive factors. So in this case, factors of 2 are just 1 and 2, right? Now, factors of 3, what do we have? Just 1 and 3. So if you start out worrying about what are the factors of the x squared coefficient and what are the factors of the constant term. Next thing you need to do, you're going to take one factor from the x squared term, multiply it by another factor on the constant term, and then add it to the other factor on the x squared term and multiply it by the other remaining factor on the constant term. So what I mean by this here, okay? What if I multiplied 2 times 3. I'm going to multiply 2 times 3, which would give me 6, right? And then if I take 1 times 1, that gives me 1. Well, if I add the 2 times 3, which is 6, plus 1 times 1, I'll end up getting that middle coefficient of 7. So this is all going to break down into what you're going to do here. You'll get 2x to the first binomials in your parentheses. The first one will be just 1x. And then in the second parentheses, since the other factor of 2 was 2, you'll have a 2x. Now, that part's easy. Since x times 2x is 2x squared, you just take the given factors that you're working with for 2. One will be an x, one will be a 2x. Now, everything's plus because we're only working with positive factors. But where do we put the 1 and 3? You want to put it in such a way that if you were to FOIL this out, you would get the original expression back. Well, we did 3 times 2. That means the 3 actually goes on the right side of the first parenthesis, right next to the 2x, because if you multiply that, you'll get 3 times 2x, which is 6x. Which means that only leaves the other factor of 3 being 1, going after the 2x plus. And then if you FOILed all this out, you would get 2x squared plus x plus 3 times 2x, which would be 7x plus 3. So you would get the original expression back. So this is going to factor into the quantity of x plus 3 times the quantity of 2x plus 1. I got some more. What if we had, so we have 3x squared plus 17x plus 10. All right, so we have the quadratic equation 3x squared plus 17x plus 10. Let's try to factor this. And some of these today we will not be able to factor, but we're going to do the best we can. So the leading coefficient, the term on your x squared, the coefficient on that is 3. The only viable factors of 3 are 1 and 3. So if we look at 3, the only factors are 1 and 3, right? Now let's look at 10. And again, this is all positive, so we only got to consider positive factors. So what about factors of 10? Well, you have 1 and 10, and then you have 2 and 5. That's really all you have. That's exactly all you have, 1 and 10 and 2 and 5. So what we need to do now is we need to figure out one factor of 3 times the factor of 10 plus another factor of 3 times the other factor of 10 that when added together will give you the middle coefficient being 17. Well, if I take 3 times 5 and then add that to 1 times 2, that would give me 15 plus 2, which happens to give me 17, right? So here's where we come in now. In your parentheses, you're going to get an x to the first term in each of your two parentheses, but your first one, you'll take that factor of 1, it'll be a 1x, so just simply x. In the other one, you'll end up having 3 times x, which would be 3x. And since everything's positive, it's going to be plus the factors. So now, what did we multiply 3 by? We multiplied that by 5, right? So that means the 5 goes to the right of the x plus because we want the 5 in the position where we can multiply 5 times 3x and get 15x. Which means the other factor of 10, which is 2, has to go here. So you would literally get 2x plus 15x would give you 17x. And if you FOILed this out, you would get the original expression back. So this is going to factor into the quantity of x plus 5 times the quantity of 3x plus 2. All right, what's next? We have 8x squared plus 18x plus 9. So we have the equation 8x squared plus 18x plus 9. Well, your leading coefficient, which is the coefficient on the x squared term, is 8. So this is where it gets interesting. For 8, you could have a couple factors. And well, since everything is positive, your x squared term should always be positive. So for that, you only consider positive factors. For 8, you have, of course, 1 and 8. And then the only other factors are 2 and 4. Those are the only other viable factors of 8. 1 and 8, and then 2 and 4. Now, let's look at factors of 9. Of course, you have factors of 1 and 9. What else do you have? Then you have 3 and 3. That's it. So you have, let's see, you have 1 and 9 and 3 for your factors of 9. Again, the goal is to figure out one factor of 8 times one factor of 9 plus the other factor of 8 times the other factor of 9 that when added together will give you the middle coefficient of 18. So let's start with 1 and 8 and 1 and 9. Well, 8 times 9 is 72 plus 1 times 1, that would give you 73. Clearly not. What if I did 8 times 1, which is 8, plus 1 times 9? Well, 8 plus 9 is 17. That's not going to work because we need it to be 18. All right, not done yet. What if I take 8 times 3? That's 24, plus 1 times 3. That would give me 27. Not going to work. So we're definitely done with 1 and 8. 1 and 8 are not viable options. All that's left is 2 and 4. All that's left are 2 and 4, I should say. Let's say I take 4 times 9, which is 36, plus 1 times 2, which would be 2. That would give me 38 for the middle coefficient. That doesn't work. What if I took 4 times 1, which is 4, plus 2 times 9, which is 18? That would give me a middle coefficient of 22. That's not going to work. So the 1 and 9s are out. Our only hope now is going to be the 2, 4, and 3. Well, if I take 4 times 3, I get 12, plus if I take 2 times 3, which is 6, 12 plus 6, ding, 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 winner. We got 18. We actually get a middle coefficient of 18. So we found our factors that work. Now, you're going to get, again, a quantity of 2x to the first terms. Your factors of 8 that you're using are 2 and 4. So that means the first term of the first quantity would be 2x. And then the first term of the second quantity is going to be 4x. And then since everything's positive and the only other factors are both 3's, you'll just have 2x plus 3 times 4x plus 3. So this will factor down into the quantity of 2x plus 3 times the quantity of 4x plus 3. All right, what do we have here next? Good one. 5x squared minus 7x plus 2. So we have 5x squared minus 7x plus 2. Okay. Well, good news is the coefficient on the x squared term is positive, so we don't got to factor out a negative sign. So, of course, now that we know the coefficient on the x squared term is 5, regardless of what the other signs are, the coefficient on your x squared term, you only want to take the positive factors of it. So, positive factors of 5 are going to be, of course, 1 and 5. That's your only hope, is 1 and 5. Now, factors of 2. The idea is, again, we're going to take factors of 5 and factors of 2 and add them together in such a way that when multiplied and added together, you'll get a middle coefficient of -7 this time. Since your middle coefficient is negative, you're only going to be able to take two negative factors of 2, right? So negative factors of 2, of course, would be -1 and -2. Because if you multiply -1 times -2, you get +2. Now, here's the question. We need to see if this works. So if we take 5 times -2, we get -10, plus 1 times -1. Well, that would be -10 minus 1. That would be -11. That would give you a middle coefficient of -11. That definitely doesn't work, right? This time, let's try 5 times -1. What does that give you? That gives you -5 plus 1 times -2. Well, -5 minus 2 is -7. So, here's how this is going to work then. You're going to have two x terms in your quantities. You're just going to take the factors for your coefficients. The first coefficient, of course, will be x. The second coefficient, of course, would be 5x for the other x of the first term. Now, we multiplied 5x by -2, right? We multiplied 5 by -1, excuse me. So that means your -1 goes here. So it's going to be x plus -1, which would just turn into x minus 1, which could only leave your -2 to go here. So, and if you FOIL this out, you should get the original expression. So this is all going to factor into the quantity of x minus 1 times the quantity of 5x minus 2. All right, we have 6x squared minus 9x plus 5. So we have been given 6x squared minus 9x plus 5. Well, the leading term on the x squared, the leading coefficient, is 6. So let's start out with some factors of 6. For that, you have, of course, 1 and 6. What else? You also have 2 and 3. Those are other two factors you have. Now, since the constant term is positive and your middle coefficient is negative, you can only take negative factors of 5. So what are some two negative factors of 5? You'd have -1 and -5, right? Because if you multiply -1 and -5, you'll get +5. All right, so let's go ahead now and play with this a bit here. If I take 6 times -5, I get -30 plus 1 times -1, so that'd be -30 minus 1. That would give me a middle coefficient of -31. That definitely doesn't work. So this time I'll take the 6 times -1. That gives me -6 plus 1 times -5. That gives me -6 minus 5. Giving me a middle coefficient of -11. That's definitely not going to work. So we know 1 and 6 are out of the question. Our only other hope rests in the 2 and 3 factors of 6. So if I take 3 times -5, that gives me -15. Plus, if I take 2 times -1, that would give me -2. -15 minus 2 is -17. That's definitely not going to work. Now, if I take 3 times -1, that gives me -3, plus 2 times -5, that would give me -10. Well, -3 minus 10, that's -13. Also not going to work. None of these work, so in other words, this is not factorable. This is an example of a not factorable equation. So unfortunately, we can't factor this. Now, if we were truly solving values for x, we could use completing the square or the quadratic formula, but that's not what we're doing today. All right, let's see. We have 10x squared minus 19x plus 6. So we have 10x squared minus 19x plus 6. So the term on the coefficient on the x squared term is 10, so let's start out by finding some factors of 10. So for 10, of course you have 1 and 10. Those are viable factors. You also have 2 and 5, and that's really all you have for 10. Now, since the coefficient on the middle term is negative, but your constant term is positive, that means you need to find two negative factors of 6. So negative factors of 6, of course you'll have -1 and -6, because -1 times -6 is positive 6. You'll also have -2 and -3, because -2 times -3 is positive 6. Now again, the idea is take one factor of 10, multiply it by a factor of 6, plus the other factor of 10 times the other factor of 6, and then see if you get a middle coefficient of -19. Well, let's start with 1 and 10. So if I take 10 times -6, I'll get -60, plus 1 times -1. That gives me -60 minus 1, which would give me a coefficient of -61. Definitely not working. Now, if I take 10 times -1, that gives me -10 plus 1 times -6. That gives me -10 minus 6, giving me -16. That doesn't work. So now we can try 1 and 10 and then -2 and -3. If I take 10 times -3, that would give me -30, plus 1 times -2, that would give me -30 minus 2, which would give me a coefficient of -32. Definitely not working. Now if I take 10 times -2, that gives me -20, plus 1 times -3, that gives me -20 minus 3, giving me a middle coefficient of -23. Definitely not going to work. So 1 and 10 is now completely out. We can't do anything with those. Our last hope is with 2 and 5. So let's deal with 2 and 5 and -1 and -6. If I take 5 times -6, I'll get -30, plus 2 times -1. Well, 2 times -1 is -2, so -30 minus 2 is -32. That doesn't work. Now, if I take 5 times -1, that's -5, plus 2 times -6, that would give me -12. -5 minus 12 is -17. That definitely doesn't work. So -1 and -6 factors are gone. Our last hope is with the factors -2 and -3. So if I take 5 times -3, what do I get? I get -15. Plus 2 times -2 is -4. -15 minus 4 is -19. We found a winner. So you'll take 5 times -3 and then 2 times -2. So now we know we can factor this. This is going to turn into, of course, you'll have your 2x in your first quantity. Second quantity, you'll have 5x. Now, both of these factors are minus, so that'll make your life a lot easier since you had two negative factors of 6. Now, we multiplied 5 by that -3, right? So that -3 is going to go right here, so you can multiply -3 times 5x. That would give you -15x, which means your -2 would have to go right here. And if you FOIL this out, you would get the original expression. So the factorization here is going to be the quantity of 2x minus 3 times the quantity of 5x minus 2. I have about 6 more. All right, this is a little bit different. So we have 3k squared plus 32k minus 11. Notice definitely for sure the coefficient on your k² term is positive. That's great. This time your middle coefficient is positive. That's fine, but the overriding result is your constant term is negative. We'll get to that in a second here. So let's take some factors of 3. The only factors of 3 really are 1 and 3. That's all you have. Now, this is where it gets interesting. It almost doesn't matter whether your middle coefficient is positive or negative. If your constant term is negative, then that's where you have to take one positive factor and one negative factor of negative 11. So you're going to treat that whole thing as a negative 11. You're going to take factors of negative 11, which would definitely be 1 and negative 11. And then there's also negative 1 and positive 11. Those are both factors of negative 11, right? Still the same process, though. Still the same process. Like, let's say what you got to do still is take one factor of 3 times one factor of negative 11 plus another factor of 3 times the other factor of negative 11, add them together, see if you get that middle coefficient of positive 32. So, okay, let's take 3 times negative 11. What would that give me? Negative 33 plus 1 times 1. So negative 33 plus 1, that would give me negative 32. That definitely doesn't work. Now, what if I took 3 times 1, that gives me 3, plus 1 times negative 11, so 3 minus 11 is negative 8. Definitely doesn't work. So 1 and negative 11 are out. Our only other hope is negative 1 and positive 11. If I take 3 times 11, I'll get 33, plus 1 times negative 1. That would be 33 minus 1, giving me positive 32. We found a winner. So 3 times positive 11, 1 times negative 1. Well, you're still going to have one factor of the k² where you would get 1k, so you'll have k, and then you'll have a 3k for the other one. Now here's where it gets interesting. When you have a negative constant, so that means one of your factors is positive or negative. It matters where you place the positive and minus sign in these. Still not too hard though. What did we multiply the 3k by? What did we multiply the 3 by? We multiplied that by positive 11. So that means here you'll have k plus 11, right? You'll have k plus 11, and if you FOIL this out, you would get 33k. Which means the only other factor is negative 1, so your negative 1 would have to go right here. And if you FOIL all this out, you should get the original expression. So this is going to factor into the quantity of k plus 1 times the quantity of 3k minus 1. Oh, sorry, k plus 11 times 3k minus 1. It'd help if I knew how to read numbers. Just might. Good grief. Okay, 5 more. (11m² plus 14m minus 16. Alright, so we have the quadratic expression 11m² plus 14m minus 16. Well, still a positive coefficient on m², which is positive 11. So factors of 11 only leaves 1 and 11. Those are the only two viable factors, 1 and 11. Now, since your constant term is negative, that means you're going to have one positive and one negative factor. So negative 16, factors of that, you'll definitely have positive 1 and negative 16. You could flip it to also be negative 1 and positive 16. What else can you have? You could have 2 and negative 8. You could have negative 2 and positive 8. And then all that's left is going to be 4 and negative 4. And then, well, yeah, that's it. I mean, it wouldn't really matter if negative 4 and negative 4, that'd be kind of redundant if I wrote it the other way. So let's go ahead now, find one factor of 11 multiplied by a factor of negative 16 plus the other factor of 11 times the other factor of negative 16. See if it gives you a middle coefficient of positive 14. Alright, so if I tell you 11 times negative 16 is going to be in the hundreds, so you're not going to land anywhere near 14. Now, what if I took 11 times 1? That's going to give me 11 plus 1 times negative 16. Well, that'd be 11 minus 16 would give you negative 5. Definitely not working. So this one's out. How about negative 1 and 16? Well, again, we know 11 times 16 will put you in the hundreds, so don't even worry about it. 11 times negative 1 is negative 11 plus 1 times 16, so that'd be negative 11 plus 16 would give you positive 5. Doesn't work. We're dwindling down the factors here. So what if I took, let's see, 11 times negative 8 is negative 88, plus 1 times 2 is 2. Negative 88 plus 2 would give me negative 86. Definitely not going to work. Now, what if I took 11 times 2? That would give me 22 plus 1 times negative 8. So 22 minus 8 is positive 14. We found it. So 11 times 2, 1 times negative 8. So that means none of these others work. So to start with here, you'll get in your first parenthesis, you'll just have a 1x, which would just be x. Your second parenthesis, you'll have an 11x. Or an m, excuse me. We used m for this. You'll have an 11m. Alright. Now, what did we multiply that 11 by? We multiplied it by positive 2. So that positive 2 will go to the left of that 11m. So you'll have m plus 2 for your first quantity, meaning your other factor of negative 8 would go after the 11m. So this is going to factor into the quantity of m plus 2 times the quantity of 11m minus 8. I have about 4 more. All right. Let's see, 18n squared plus 9n minus 14. So we have 18n squared plus 9n minus 14. Well, let's start by finding some factors of 18. So for 18, well, of course you got 1 and 18. That'll always be 1 in itself, but you also have 2 and 9. And then you also have 3 and 6. So there are 3 sets of factors for 18. Now, since the constant term is negative, that means you need to find one positive and one negative factor for negative 14. So negative 14 factors of that, you would have positive 1 and negative 14. You could also have negative 1 and positive 14. What else could you have? You could have 2 and negative 7. Then you could have negative 2 and positive 7. So there's all your factors listed out. Now, let's go ahead and see what factor of 18 times the factor of negative 14 plus the other factor of 18 times the other factor of negative 14 when added together will give you a middle coefficient of 9. Well, 18 times negative 14 would be very large into the hundreds, so definitely not going to put you anywhere near 9. Now, if I took 18 times 1, that gives me 18 plus 1 times negative 14. That gives me 18 minus 14, which would just give me 4. That's definitely not correct. Well, again, 18 times positive 14 would be very large into the hundreds, and then that's not going to work. Now, if I took 18 times negative 1, well, that would give me negative 18 plus 1 times 14. That give me negative 18 plus 14, giving me a middle coefficient of negative 4. That doesn't work. Let's see, 18 times negative 7 is still over 100. Then you would just add 2 to that. You're going to be nowhere near 9. But if I took 18 times 2, I get 36 plus 1 times negative 7. So 36 minus 7, 36 minus 7 is going to be 29. You need just 9, not 29. So that doesn't work. All right, so then what if I took, let's see, 18 times negative 2 is negative 36 plus 7. That would give me negative 29. That doesn't work. So 1 and 18 are officially out as factors. Now what about 2 and 9? Well, 9 times negative 14 would still put me over negative 100. So you'd be nowhere near 9 for your coefficient. But if I took 9 times 1, that'd be 9, plus 2 times negative 14, that'd give me 9 minus 28, which would give me negative 19. That definitely doesn't work. Now, let's see, if I took 9 times negative 1, that would give me negative 9 plus 2 times 14 would be 28. Negative 9 plus 28 is positive 19. That doesn't work. All right. 9 times negative 7 is negative 63 plus 2 times 2. So negative 63 plus 4 gives you negative 59. That doesn't work. Now, if I took 9 times 2, that's 18. Plus 2 times negative 7, well, that would be 18 minus 14, which would give me 4. Doesn't work. All right, last hope here. 9 times 7 is positive 63 plus 2 times negative 2, so you get 63 minus 4, which would give you positive 59. That doesn't work. 9 times 2 is negative 18. 9 times negative 2 is negative 18, plus 2 times 7 is 14, so negative 18 plus 14 is negative 4. That doesn't work. So 2 and 9 are out. Your last hope is going to be with the 3 and 6s. Well, we definitely know 6 times the 14s will give you still a number. It would be under 100, but it would be way larger than 9. So, yeah, that would end up being 84, should be. But that would put you nowhere near 9, so none of these two factors work. We can cross those out. We know that. Our only hope is with these two set of factors. If I took 6 times negative 7, what does that give me? Negative 42 plus 3 times 2, that'd be plus 6. So negative 42 plus 6 is negative 36. Definitely doesn't work. So 6 times 2 is 12. All right, so yeah, 6 times 2 is 12, plus 3 times 7 is negative 21. 12 minus 21 is negative 9. Real close, but we need a positive 9. Which leads me to believe it's this set of factors here. So 6 times negative 2 is negative 12, plus 3 times 7 is positive 21. So negative 12 plus 21, what do you know? It's positive 9. We finally got something that works. So 6 times negative 2, and then 3 times 7. Now that we got evidence that this will factor, one of the factors would be, of course, you'll have 3n for the first term of the first factor. The other term, you'll have 6n for the first factor. Now, what did we multiply 6 by? We multiplied 6 by negative 2. So that plus negative 2 will go immediately to the left of that 6n. So you'll have 3n minus 2, which means your only other factor is plus 7, which would go right here. So this would factor into 3n minus 2, that quantity, times 6n plus 7. I should only have 3 more. All right, 7u squared minus 4u minus 3. All right, so we have 7u squared minus 4u minus 3. So, of course, let's start with the coefficient on the u squared term. That's 7. So we need to find factors of 7. Well, that's pretty easy. That just leaves 1 and 7, right? 1 and 7, that's easy enough. Now, we don't care for a moment that the middle coefficient is negative, but we do care that the constant term is negative, which means we need to find factors of negative 3, which would give you 1 positive and 1 negative factor. So factors of negative 3, you could still have positive 1, but the other factor would have to be negative 3. And then it could switch around to negative 1 and then positive 3. So we need to see if any of these factors, when multiplied and added together, produce a middle coefficient of negative 4. Alright, so what if I take, let's see, 7 times 1 is going to be 7, plus 1 times 3, that would give me 7 minus 3, that'd give me positive 4. That doesn't work, and 7 times 3 would be negative 21, putting you nowhere near it. But what if I took 7 times negative 1? That'd be negative 7 plus 1 times 3, so negative 7 plus 3, what do you know? It gives you negative 4. So you'll take 7 times negative 1, and then you'll take the 1 times 3. Now we know this factors, let's set this up. So your first factor here, the first term of the factorization will be the 1u, or just simply u. And then you'll end up having 7u for the other quantity. Now, we multiplied 7 by negative 1. So that negative 1 is going to go right here, immediately to the left of the 7u. So you'd have u minus 1, meaning your other factor is positive 3. So this will end up factoring into the quantity of u minus 1 times 7u plus 3. And I only have 2 more. V squared minus 25v minus 7. Alright, so we have 12v squared minus 25v minus 7. So let's start with factors of 12 on the v squared term. So factors of 12, well, of course you have 1 and 12. That's a given. You also have 2 and 6. You also have 3 and 4. So those are your 3 sets of factors for 12. Now, the constant term is negative, so that means we need to find a positive and negative factor of negative 7. Well, negative 7, you have 2 sets of factors. You could have positive 1 and then negative 7, or you could have negative 1 and positive 7. Now let's see if one factor of 12 times another factor of negative 7 plus the other factor of 12 times the other factor of negative 7 will add up to be a coefficient of negative 25. So, well, we know 12 times negative 7 will give you negative 84. That would put you nowhere near negative 25. And if I did 12 times 1, that's going to give me 12 plus 1 times negative 7. That's going to end up giving me then 12 minus 7, which is 5. Definitely not working. Now if 12 times 7 is positive 84, putting me nowhere near negative 25. 12 times negative 1 is going to be negative 12 plus 1 times 7, so you'll get negative 12 plus 7 is negative 5. Not going to work. So it's very clear then that the 1 and 12s aren't going to work. We still have 2, 6, and 3, and 4 to go through. 6 times 7 is negative, 6 times negative 7 is negative 42. Then if I just added 2, that give me negative 40. That puts me nowhere near negative 25. Now if I, let's see, 6 times 1 is 6, plus 2 times 7 is negative 14. 6 minus 14 is negative 8. That doesn't work. 6 times 7 is positive 42. The minus 2 would give you 40. That still doesn't work. 6 times negative 1 is negative 6, plus 2 times 7 is 14. Negative 6 plus 14 is positive 8. That doesn't work. So 2 and 6 are out the window. That just leaves 3 and 4 here. So let's see, 4 times negative 7 is going to be negative 28. Plus 3 times 1 is 3. Well, negative 28 plus 3 is negative 25. We actually got it to work. So 4 times negative 7, and then 3 times 1. Now that we know this factors, the first term of your first quantity would be 3v. The second term of your second quantity is going to be 4v. Alright, so what did we multiply the 4 by? The 4 was multiplied by negative 7, so the negative 7 would go immediately to the left of the 4v, which leaves your only other factor, positive 1. So this would factor down into 3v minus 7, that quantity, times 4v plus 1. I got one more problem, then we're done. Okay, let's give you 4w squared minus 13w minus 27. So we have 4w squared minus 13w minus 27. So let's start with factors of 4 on the w squared. So 4, of course you have 1 and 4, but you also have 2 and 2. Those are the only other factors of 4. Now, the constant term is negative 27. Since it's negative, we need to find a set of positive and negative factors for it. So negative 27, you have, of course, positive 1 and negative 27. Then you have negative 1 and positive 27. Then you have, of course, positive 3 and negative 9. Then you have negative 3 and positive 9. That's about all you have for negative 27. Okay, let's get into this here. So if I took 4 times negative 27, that would give me negative 108 plus 1. That would give me negative 107. That doesn't work. If I took 4 times 27, that would give me positive 108. Minus 1 would give me positive 107. That doesn't work. Alright, let's see. 4 times negative 9 is negative 36. Then plus 3, that gives me negative 33. That doesn't work. 4 times 3 is going to end up being 12. 4 times 3 is 12. Then minus 9 is positive 3. That doesn't work. Now if I took, let's see, 4 times negative 3, that would give me negative 12, plus 9 would give me negative 3. If I took 4 times 9, that gives me 36, and then minus 3 is positive 33. So 1 and 4 entirely don't work. Our only other hope is 2 and 2. So 2 times negative 27 is negative 54, plus 2 would give me negative 52. Not going to work. 2 times 27 is 54, minus 2 would give me positive 52. Not going to work. So we're going down the list of what doesn't work. 2 times negative 9 is negative 18, plus 2 times 3, which is 6. Negative 18 plus 6 is negative 12. We're real close, but that doesn't work. And then we have 2 times 9 is 18 minus 2 times 3, so 18 minus 6 is positive 12. None of these work, so this is not factorable. We actually have a non-factorable one. So if you were to solve the values for W, you would either need to complete the square or use the quadratic formula. Those would be your only other options. So that's it for this lesson. Now we've covered all the ways you can factor a quadratic equation. So the next lesson we're going to use them to solve quadratic equations. We'll actually be finding values for the variables. So I hope everyone has a great day. Take care.